Hello all and welcome to this video. In this video, I will provide a brief overview on artificial intelligence. So let's get started. These are some reference URLs that I have posted over here. I would recommend that you visit these URLs as they have additional information on this particular topic. I will also have these URLs posted in the description of this video. So, what is artificial intelligence? Artificial intelligence is the field of computer science that is dedicated to solving cognitive problems associated with human intelligence, such as learning, creation, and image recognition. In very simple words, what we are trying to do is we are trying to enable computers and machines to simulate human intelligence and problem solving capabilities. So, the reason why AI is known as AI is because of the fact that we are trying to simulate human intelligence. So, artificial intelligence, that term essentially comes from from simulating human intelligence. So, intelligence, of course, comes from human intelligence, and since it's a simulation of human intelligence, and it is man-made, right? It's made by humans. Hence, it is called as artificial intelligence. That's why the word artificial is over there. Artificial intelligence technologies are self learning data driven systems that derive meaning from data and apply knowledge to solve problems just like how humans would. So, for example, you have digital assistants, you have GPS guidance, you have autonomous vehicles, you have Gen AI tools like Chat GPT. So these are some of the artificial intelligence technologies that are available right now. Now, one of the things that you might have noticed is that AI and ML are used interchangeably. So, but what is the difference between them? So, very briefly, uh, everything that is machine learning and deep learning is AI. Why? Because machine learning and deep learning are subdisciplines of AI or artificial intelligence. In fact, deep learning is a subdiscipline of machine learning. So everything that is deep learning is machine learning. Everything that is machine learning is AI because they are subdisciplines of AI. And hence, everything that is deep learning is AI because deep learning is a subdiscipline of machine learning and machine learning is a subdiscipline of AI. So hence, everything falls under AI. So hopefully that was clear. Now let us understand how does AI work. Now, you must have heard this from a lot of people. AI typically works on data. AI is a data-driven technology, as I mentioned earlier as well. So there are a lot of different AI techniques, but all of those AI techniques, they work around data. No data, no AI. So a lot of times I have seen from my experience that organizations are very keen on implementing AI, but they are not very successful in doing that. The reason behind it being is that AI needs data and needs good quality data. If that data is not available, then implementation of AI will not be successful or AI will not work. Now, AI systems learn and improve through exposure to vast amount of data. And essentially what they do when they're exposed to this, this enormous amount of data is they start identifying patterns and relationships that typically humans do or sometimes even humans miss. And hence, AI can, let's say do a better job sometimes than humans because a certain amount of human error that is involved. Remember, AI is programmed. It is programmed to do certain things and it is trained to identify certain patterns or relationships. Of course, that's a very narrow set compared to what a human can do. Now, this process often involves algorithms, of course, which are a set of rules or instructions that typically guides AI to perform any kind of analysis or decision making. Now, in machine learning, which is of course a popular subset of AI, as we discussed earlier, These algorithms are trained on labeled and unlabeled data to make any kind of predictions or categorize information. Deep learning, which is again a subset or a subdiscipline of machine learning, that is a specialization of machine learning, behind the scenes uses artificial neural networks to process all of this information. And these neural networks, we will just look at it in a little bit, typically mimics the structure of a human brain. So continuing further ahead, these are some of the technologies that make artificial intelligence work. So first one, of course, is neural networks. So what is a neural network? As the name suggests, there are two words in this, right? Neural and network. Neural is from neurons that are present in a human brain. And network is basically connecting all these neurons to basically form a network so that data or information can flow along it, just like how a human brain works. So neural networks essentially simulate or mirror the processing that happens in a human brain. It contains, the human brain typically contains billions or millions of neurons that process and analyze information. Remember, everything that is AI is a simulation of human intelligence. So what we are doing over here is we are simulating neural network that is typically present in a human brain. Hence, it is called as artificial neural network, which uses artificial neurons that process information. Of course, each neuron or each node uses mathematical calculations to process this information and solve complex problems, just like how a human brain typically does. Hence, it is called as neural network. So, in very simple words, a simulation of how a human brain works. That's the simplest definition of neural networks. After that, we have natural language processing, or popularly known as NLP. Behind the scenes, NLP also uses neural networks to interpret, understand, and gather meaning from all the textual data. And it uses different computing techniques. It specializes in decoding and comprehending human language. And hence, you will see that when you are communicating with an a natural language processing system or a model, you basically communicate in text and you communicate with it in a human language, typically English. But now you do have models that communicate with some other languages as well. After that, we have computer vision, which is very popular. You probably already know or are aware of that, right? Computer vision basically uses deep learning behind the scenes to extract information and insights from videos, images, even text, just like how typically a human would. Again, it's a simulation. Then we have speech recognition, which also uses deep learning models to interpret human speech, identify words, detect meaning, and neural networks can also transcribe speech to text and also help you to understand the sentiment behind that particular speech or text. And we also have finally Gen AI. Gen AI is probably the most popular form of AI that is used to create new content, images, different artifacts, videos, audio, deepfake, from simple prompts. You give it a prompt that, hey, I want to create this kind of an image, and it will use all of its data to generate that kind of image for you. So it basically takes input as a text prompt and then finally gives you a video or an image or maybe some other form of text or audio as an output. Moving further ahead, let us see what are the different types of artificial intelligence. Now, artificial intelligence are grouped in two types. First is capability based, and second is functionality based. So, let us look at capability based. Capability based artificial intelligence, there are three types. First is narrow AI, then we have general AI, and then we have super AI. Now, what we know AI right now, as AI is right now, is called as narrow AI or weak AI. This is the type of AI that exists today. All other forms, that is general AI and super AI, are theoretical in nature. Now, what is narrow AI or weak AI? Narrow AI or weak AI can be trained to perform a single task or a narrow task, and it often does a faster or a better job than typically a human mind. Right? Because remember, it's a programmed set that is programmed to do a specific task, and it reduces the human error and the chances and the probability of human error occurring significantly. Hence, it can outperform humans while performing a very specific task. And it basically targets a subset of human cognitive abilities and advances in that particular ability. For example, Siri, Alexa, ChatGPT, Watson. All of these are examples of narrow AI because they excel in one specific thing. Moving on to general AI. Now, general AI is also known as strong AI. As I said earlier, only narrow AI and weak AI is what exists today. So, strong AI and general AI is basically a theoretical concept. The intention is to develop this AI. There's a lot of research happening in this area as well. And the uh, the intention is to form that kind of an AI that can accomplish new tasks and without any kind of human need or intervention or even having a prior context of what that task is all about. So again, we are trying to simulate human behavior or human intelligence over here. And if we are able to generate this kind of intelligence, which is strong AI or general AI, then they will basically most likely outperform humans and probably perform some of these human tasks at mostly very well. Now, super AI, again, strictly theoretical. This is something probably you might have seen in a lot of sci-fi movies. So super AI is again, the developing something that can think, reason, learn, and make judgments, just like how humans can, and also possess cognitive abilities that surpass human beings. So this is going beyond human intelligence. So now human intelligence is trying to create something that can go beyond human intelligence. So again, it's a theoretical concept. We will see how things progress further ahead. But right now, this is only something that you see in different sci-fi movies. Now let us look at the different types of artificial intelligence that are functionality based. The first two that I mentioned over here, these are based on narrow AI. So the first one that we have is reactive machine AI. Now, reactive machine AI does not have any memory. They are designed to perform a very specific task and they work with the data that is available to them. They analyze vast amount of data to produce a seemingly intelligent output. For example, IBM's Deep Blue, that is a chess playing supercomputer that beat Gary Kasparov, I think somewhere in 1990s. And we have Netflix recommendation engine that basically, gives you recommendation depending upon what content you would most likely enjoy. But these form of AIs do not have any memory. Okay. Now let us go to the second one, which is limited memory AI. Now, as we discussed earlier, reactive machine AI does not have any memory. Limited memory AI, as the name suggests, does have some memory and it can recall some past events and accordingly some of the past outcomes and monitor specific jobs and situation over time. Now, since it has limited memory AI, it can use some of its past and present data to decide a course of action that needs to be taken and accordingly achieve a desired outcome. It is trained over a vast amounts of data and over a period of time it has been observed that the more data you give to these systems and the more you train it, its performance has improved. For example, you have ChatGPT, that you have some visual assistance or chatbot assistance as well, like Siri, Alexa, or you have autonomous vehicles or self-driving cars. But both of these forms of AI are narrow AI. The next two forms is theory of mind and self-aware AI. Now, theory of mind is a form of general AI. Remember, general AI is a theoretical concept and it is not a realized form of AI as of today while I'm recording this video. Now, the intention is to create a form of AI that would understand the thoughts and emotions of other entities, especially other humans, and would also allow you to simulate human-like relationships. Again, this is theoretical. You can probably, associate something like the movie Avatar, where you had, AI working with humans, and we are trying to simulate human relationships. Right now, all of this is available in sci-fi movies. And finally, we have the self-aware AI, which is based on super AI. It has super AI capabilities. Remember, we are trying to even surpass humans and human intelligence, but the ability of the self-aware AI is that it is going to have its own internal conditions, its own internal traits, its own emotions, its own thoughts, its own beliefs. So, just like how a human has, the intention is to simulate human beings now with not just its intelligence, but also the emotional side of humans. The emotional sides, its emotional needs, its beliefs, its faith. They're trying to simulate that. It's theoretical, super theoretical, it's just a concept. We will see how things, progress further ahead. Sometimes the feedback that I have received, especially for super AI, is that it can be uh, very, you say, scary. It is scary because it's surpassing human. So we will see, but there's no reason for you to get scared right now. Just like anything else, AI has its own set of challenges. And these are some of the challenges. Of course, there are many more challenges that are associated with this. So first is AI governance. So managing data quality, privacy, security, data accuracy, right? All of that comes in, but putting governance uh, to ensure that good quality AI models are developed and it is using the data, the customer data in the right manner is very, very critical. So any kind of AI governance or putting governance around development of AI is one of the biggest challenges. The next challenge that a lot of people have faced is technical difficulties, and that is because remember, AI thrives on data. Data requires a lot of hardware or machines, a lot of disk, a lot of processing power, and all of this can be significantly costly or limiting. And because it can become expensive and limiting, it can limit your AI system's ability to scale. So essentially, especially with deep learning technologies, you require a lot of processing power. And that can essentially be, let's say, a roadblock while you're trying to develop your deep learning models or your ML models or your AI capability. Data limitations. So as we said, data quality, privacy, security, accuracy, managing overall data, all of these are super uh, challenges when it comes to AI implementations. Remember also the data that you need to have should be the right type of data that you can use to train your AI model in an unbiased manner. And that's where responsible AI, which is the right part, the next part over here, sorry, responsible ethical AI plays a critical role as well. So, how to ensure that whatever is being developed, uh, you know, is right for humans, is right for mankind, and is being developed considering the different social, environmental impact and implications that this system will have going forward in the future. So that is also one of the biggest challenges that we face today. So these are some of the top challenges. Of course, as I said, there might be other challenges as well, but these are some of the top challenges. If asked in an interview, you can say that, hey, these are some of the challenges that we face right now. Benefits. So by now you should have understood or the benefits of AI. Of course, the top one is automation. Second is reducing human error. It is fast and accurate. It boosts productivity, and yes, it solve or helps solving complex problems. Some of the use cases, speech recognition. Of course, you are aware of that. image recognition, a lot of tools around the corner, translation, so translating written or spoken words from one language to another language, predictive modeling, so mining data to kind of, forecast certain outcomes with certain specific level of accuracy and granularity. Data analytics, one of the most popular field to find patterns, relationships, and data, and then using that for business intelligence. And somewhere where AI has taken or is absolutely significant is cybersecurity. It's really taken off in this space because you can use AI to scan networks for cyber attacks and threats, which is the biggest challenge that we are facing in this super cyber connected world. So these are some of the use cases for AI. Now, moving on to AWS services for AI, what are some of the services that are available? So we do have some pre-trained services like recognition, extract, and transcribe. I have created videos on all three of them. Please go to my channel if you want to know more about what these services do. There is a lot of information available. There are some of the AI infrastructure services as well, like Bedrock, SageMaker. Now, SageMaker is primarily a machine learning service, but since machine learning is a subset of AI, is put over here. But not everything that is machine learning is AI. So not everything that is AI is machine learning. But typically, SageMaker is associated to be a machine learning service. It can certainly be used to create models that can be used by Gen AI services like Bedrock. And finally, we have EC2. Now, EC2 has TRN1 instances that are powered by AWS Titanium chips and are typically used for high performing deep learning training of generative AI models. Remember, one of the challenges is processing power, and that's why these instances have been developed. So they can power some of these deep AI training of different models. So hopefully this overview was helpful. So if you're going for an interview or anywhere now, you know what AI is, different types of AI, capability based, functionality based, challenges, some of the AI services that are popular, both pre-trained services and AI infrastructure based. So using all of this knowledge that I have just shared with you, using your human intelligence, right? You can certainly come up with very intelligent answers for your interviews or if any questions are asked to you. So this is it from me today. Hopefully this video was helpful. Do post your comments and I will see you shortly in some other video. Till then, take care. Bye-bye.